Hello. I'm in Harris. I was with a colleague, Shan, but she's unfortunately withdrawn from the course this year. So I'm flying solo here, so bear with me. I have a lot to get through, so I'm going to rush, but I hope it makes sense. I'm going to talk about an NTP Reflection Attack, which is a type of denial of service attack. Many of you might not know what NTP is, so I'm covering that quickly. It's a network time protocol used across devices to give you a very accurate and synchronized time signal. So the idea is you take a signal from GPS satellites, atomic clocks, and then you cascade those down through devices until you've got a network of time servers, which is what I'll be looking at specifically today, which are available to the general public so that you can synchronize your devices to them. So the last level here, workstations, mobile phones, iPads that synchronize with the time servers. So my attack specifically is going to be looking at this kind of level. All this is a bit high engineering and technical. I'm not going to worry about that. So many of you will be aware of what DDOS is, or Distributed Denial of Service. Typically, many machines across the internet will simultaneously attack a target, requesting service, requesting site from them, and if you hit it with enough traffic, you're able to bring that service to its knees and unable to respond. If you've got lots of clients, typically zombie PCs out there, they will be able to overwhelm the service, come from multiple different directions. It's very hard to filter to it. However, also a quick schematic of what that typically might look like. So attacker, one lone attacker, he might have control of a handful of master PCs, which he then uses to control many slaves, which potentially have been attacked by one of the exploits that we're hearing about. I'm not looking at this level. Those slaves will then request all the traffic that they can from the victim. So that's a traditional denial of service. One of the problems with that is that all your individual clients have to have quite a lot of bandwidth to pull down as much traffic as they can, or you have to control many thousands of individual machines. So, I mean, around the world, okay, our average around the world for broadband connections are about 17 meg. Some of you in Aberdeen may not even be getting that, but around the world, that's the average. So if you want to get a lot of traffic, you need a lot of machines to put each pull down to 17 meg. So that you have to get a lot of machines in your zombie. Whereas what I'm looking at specifically is a refinement to that attack, which is called a reflected denial of service. So the idea is that rather than using lots of zombie PCs to do all the work for you, you can use a few high-performance hosts, typically servers, that you can bounce your traffic from. So one highly connected internet host may have several gigabit connections, it'll have a lot of memory, it'll have very high bandwidth. So you can use that attack to generate the traffic for you. So some of these have been quite common in the past. DNS and SNMP have been used previously for these reflected attacks. But specifically, I'm going to use NTP, which is why I talked about NTP briefly at the beginning. One of the benefits of using a reflected attack is this amplification that they talk about. That you can send as an attacker a very small request and bounced back from the server, you get a very high volume of traffic. So that's what you're looking for, as much amplification as you can. So my small laptop sends a small request, bounces off an internet connected server, and generates gigabytes of traffic for me, so I don't have to do the hard work for me. So slightly different graphic, there are lots of extra lines, but your attacker controls a few masters, which control a few slaves, but each of these slaves bounces traffic off servers that are out on the internet, and they then reflect to the victim. So you've got some low bandwidth connections here, but these connections here will be super high bandwidth and generate very large volumes of traffic to attack the target you're looking for. So to do this, I'm using nping, which is part of the Nmap suite that we heard about this morning. So it's just as well I've been going to Nmap in particular. So it's an open source tool from Nmap that lets you generate your own packets. So you can specify your source IP address, your source ports. You can specify the target that you're looking for. You can generate your own custom payload. So it may be that you are duplicating some other traffic. You can modify the packet contents itself and send that with you. You can specify how quickly and how often and the rate of sending packets. That lets you control how much bandwidth I'm actually going to use. So, okay, it's a quick diagram of what a UDP packet would look like. So you've got the source address and destination address at the top, what protocol you're using. I'm going to set that to the NTP protocol. You've got how long this particular packet is, but you've got the source port and destination port. And I'm going to be playing with the source port and source address to allow me to reflect to my target. The source port can be any valid UDP port. I don't care where this traffic really ends up when it hits my target. So long as it's a port on the target, it can be closed, I'm going to flood it, but if it's open, if it's listening, or if it's stealthed, if I can hit that port with some data, that port has to process whatever I'm sending to it. It might be that it just says, I don't understand this is garbage, and rejects it, but it requires some resource in the target host to actually understand what I'm sending. So if I can hit a valid UDP port on my target, great. If I can't, I'm still going to flood it with lots of traffic. Time runs on port 123, so I'll be requesting some service from the 123 port on my internet servers, which I will then throw to my target, which is, in this case, a spoofed internet service. The data, the last bit at the bottom, is the hex data from a valid query. So what I've done, I used Wireshark to watch some valid traffic for NTP, re-engineered those packets to let me change the source address and the source port, and then I can send them as many times as I want. So just to summarize that, attacker will use NPing to send custom packets at a reasonable rate as he can. I've said fast as possible, but that's probably your uplink from your home is your slowest link. Your packet payload that you've customized is in hex, this string, and that string will ask a time server to respond with all the list of other PCs, other servers that have synchronized the time. So that list can be quite long. If you've got an internet host that's serving time requests to many devices, that list could be quite long. Theoretically, up to 600 devices would respond. So one, 70-byte string could respond with 200, 300 times the response. So that's the amplification you're looking for. As much more traffic as you can to a small enough request. This actual attack was used just in February to generate a world record for a denial of service, depending on who you talk to, whether or not it's true or not. That they reckon Cloudflare, which is a cloud-based service provider, was hit by 400 gigabits of traffic, which is an extreme amount of traffic for any service provider to try and deal with. So when you hit a service with that, lots of things stop working. Routing will stop working, you'll take out links, servers won't be able to respond. So for my practical demonstration, which I'm crossing my fingers will actually work, I've got a bunch of kit here, but specifically I've got a Raspberry Pi, chosen because it's a fairly low power target, so it gives me an effort to show that in a reduced context. My attacker, I've got a little old MacBook running Mint. I was proposing to have 2 MacBook laptops as NTP servers, but I'm -1 at the moment, so I'm half power, but it still works. So the impact will be that my Raspberry Pi, which is pretending to be Netflix or fake flicks, will be unable to stream the video that the client is trying to get. I've removed a couple of layers from that diagram because I just didn't have enough equipment to use. So I'm just using one attacker to bounce off one server to hit one victim. So, schematic of kind of what we're talking about. You've got your end user on his iPad streaming from a hosted service, in this case Netflix. The attacker, which is my, it was a Dell laptop, but I don't have that. The attacker will bounce its traffic to the 2 time servers through the internet. Those 2 time servers will then bounce the traffic back to the Raspberry Pi, because I have spoofed my source address. As far as the time servers are concerned, the Raspberry Pi has kept asking for this data. So the servers reply back to the Raspberry Pi. Eventually, the Raspberry Pi, flooded with traffic, can't keep up. It will be unable to continue streaming traffic to the iPad. In a bigger context, you can imagine that this web server, this Raspberry Pi, could have a database server, it could have a network attached storage, many devices on its network. And if I can break its network link or flood it, it's unable to contact whatever database servers, whatever storage that it actually needs. Potentially, again, if I hit the correct open ports or listening ports, I can actually cause that server to generate more and more process, more and more memory will be used, and eventually it's really broken at that point. So, hopefully, I should be able to demonstrate my attack at this point, right? So NTP. So at the moment, I can request what data my server is listing. So this NTPC, I realise it's quite small, just gets the current list of what clients have asked the time from this server. At the moment, nothing. There's no other devices synchronizing the time. What I should be able to do is, using my netbook, is actually display a new list, or populate it with a list of new clients. Right. Change the sheet here. Okay, so I have a couple of bash files set up here, which I can use to send commands to the time server. First one, I'm going to, that's the wrong one, sorry, wrong script. Okay, so this first script will populate lots of clients as if they were using the time server. So I'm just going to run that. So that script has populated lots of IP addresses into my time server, which unfortunately I can't show you, but I'm actually seeing a list of 200 IP addresses. So this script has populated my time server with lots of fake clients. So I've spoofed lots of IP addresses to populate my time server. Using the second script, what I'm going to do is I'm now going to request again and again and again and again and again that list of client IP addresses. But I'm sending it back to the Raspberry Pi, and I'm also sending it back to a random port each time, just to give me a shotgun effect, so I can cover as many different ports on the Raspberry Pi as possible. So look at that. So that script, albeit really, really fast, is sending lots of traffic to the Raspberry Pi on various different ports. So I'm hoping I should find on my browser of course I've started the attack now, so I'm not going to get any response from it at all. Let me just kill that. Expecting a screen from the iPad there. That's unfortunate. Okay.
So this is the device you are using to test if the connection is working.
Yeah, so I'm
this
trying
was the last step of your day.
Last step, I was going to demonstrate the
Can you just
video.
try to show us what you have on your screen?
So, that's unfortunate. So I've got a fake Netflix website here, which would have been streaming hackers, but has stopped working, custom privilege. So the central content of that would have been the hackers video, but if I kill my content,
If you stop the attack.
yeah, that's what I'm going to do. I'll do it the easy way, pull the network cable out. There's that page. So this may take a second to figure out when the traffic stopped, because I have been able to hit up to a gigabyte of network traffic coming out the switch, which I'm slightly disappointed. By the looks of it, I may have actually broken the Raspberry Pi completely. Yeah, it's still thinks it's receiving a lot of traffic.
It was stronger than what we were
That's
expecting.
good, There we go. Right, okay, I've pulled the time server out of the connection now. So I can now actually get some response from the Raspberry Pi. So I'm changing the different video streams there.
Okay.
Yeah, so that's now responding again. If I start the attack, the stream will stop and I'll find pages not unavailable to host.
Okay.
Sorry about that. Technical cover.
Okay. So do you have any questions?
Any questions?
No? No questions at all? No? Okay. You said that you are sending the queries you sent for the reflection attack. You sent them on different UDP ports.
Well, I'm always hitting 1, 2, 3 on the time server, but I bounce it back to different ports on the Raspberry Pi to give me a.
Okay, and did you hit the port that you are using for streaming, or that was?
I might have, I don't know. I've set it as a random range, so it just hits
It's
lots of
UDP,
ports.
yeah?
Yes.
Because you might have coded by as well, yeah. Okay. Okay. I think that's fine. Thank you very much.